Everyone. So we have already seen the three important services that a transport layer provide, right? Process to process communication, then addressing we have seen, encapsulation and decapsulation we have seen, right? So now what is the fourth service that a transport layer provide is multiplexing and demultiplexing. What is multiplexing? In simple words, you can say is whenever an entity receives items from more than one source, okay, whenever an entity receives message from more than one source, it is multiplexing, and whenever an entity delivers message to more than one source, it is demultiplexing. Okay, it is many to one. Accepts message from more than one source, delivers message to more than one source. It is one to many. Okay, so now see this example, see this diagram. Okay, so transport layer at sender, it acts as, at client side, it acts as a multiplexer, and at the destination side, it acts as a demultiplexer. Okay, so at source side, it acts as a multiplexer, and at destination side, it acts as a demultiplexer. How? So whenever an application like this here, you can see application sends these 4 messages to transport layer. Okay, so it acts as a multiplexer. It accepts that 4 messages, make them into packets, add the transport layer header to it, the socket address, and then sends those to the destination. At destination, the header destination, what happens? Decapsulation happens. It removes the header, right? Then it sends those packets to demultiplexer. It acts as a demultiplexer. What demultiplexer do is it takes this message and sends to more than one source, different processes, right? At application layer. Okay, so it acts as a multiplexer. It accepts messages from different process, convert them into packets, add the transport layer header, encapsulated, sends those to destination end. At destination end, decapsulation happens, and it acts as a demultiplexer. It sends those message or those packets to different processes. Okay, so this is the fourth service that a transport layer provides. It acts as a multiplexer as well as demultiplexer. Okay, so now let's see the 3 important controls that a transport layer provide. First one is flow control. Second is error control. Third one is congestion control. Okay, so let's discuss it one by one. Okay. Okay, so the first one is flow control. So what is flow control? The name can suggest you that the flow should be in control, right? So flow control means that the sender or the producer should not overwhelm the consumer, the receiver, by sending packets, by sending messages, the rate which is higher than the rate the consumer consumes that packet. Okay, so the production rate and the consumer rate should be in balance, right? Producers sends message chunks so ran so fast, right? And consumer can't consume that message at that rate, right? So at that time, consumer is overwhelmed, right, by the producer by messages, right? So that condition is called flow control. Okay, so flow control means the rate of production and rate of consumption should be in balance. Okay, sender is not overwhelming a receiver by sending packets the rate which is higher than the rate consumer consumes it. Okay, so this is called flow control. Okay, if the flow is not in control, then you have to have the flow control. Okay, so now this is the meaning of flow control. Okay, so how flow control, or the two terms here are, means producer sends items to consumer, right? So the delivery of items from producer to consumer can happen in 2 ways. There are 2 terms for that. First one is pushing, second one is pulling. So from diagram, it is clearly self-explanatory. Means pushing means producer is pushing its messages to consumer, right? Whenever producer have a message, it's just without the prior request of the consumer, it just pushes that message to consumer, right? And pulling means when a consumer request, okay, hello producer, send me a message, then producer sends those message to consumer. This is called pulling. Consumer pulls the message, it sends a request. And here pushing, producer, whenever producer has a message, it's just push on to that to the consumer. So here is the higher need of flow control, right? Because here, whenever consumer request, whenever consumer is in need, at that time it asks. So flow control is not needed, right? Here the flow control mechanism is needed because producer is just pushing that message to consumer, right? So now how the question is how flow control is managed? What is the flow control mechanism it at transport layer? Transport layer provide flow control, right? So how it provides? Let's just see this example. Okay, so here what happens, flow control should be there at consumer and at the client, the host end, the source host end, and the destination end, the sender end and the receiver end. Both sides you have to have flow control. Why? Because whenever application layer has a message, right, it just push on that message to the transport layer, right? So here you need a flow control. Wherever pushing happens, you need they at that place you need a flow control mechanism, right? So whenever application layer has a message, it just push on that message to the transport layer. Okay, so here you need one flow control, the source side. Okay, then what happens? Transport layer receives a message, it transforms it into packet, encapsulated at the header, then it pushes that message to the destination end, right? So here packets are pushed, so here flow control is needed. At last side, the decapsulation happens, the destination side, the decapsulation, it removes the header and sends those packet to application whenever application layer requests it. Okay, so at last stage, application layer request the transport layer, okay, send me a packet now. At that time only messages are pulled. So here flow control is not needed, right? So we need two flow controls at here at the source end and at the receiver end. This thing is understood, right? So now how we manage this flow control. So for that we need buffers at two ends, at sender end and at the receiver end, right? Here we need a buffer and here we need a buffer. What is a buffer now? Buffer is the set of memory locations. They are the memory locations that can hold your packets at the receiver end and at the sender end respectively. Okay, so buffer are nothing. They are the set of memory locations. They are buffer. They are the memory locations. So memory location is there which hold your packets. Okay, so what happens? What happens at sender side? Whenever application layer sends a message, it holds that packet, right? And when the buffer is full, it sends the message to application layer. Okay, application layer, now please just stop sending me message. I am full. Okay, whenever my vacancy is there, I'll inform you. Okay, same happens at receiver end. Whenever receiver side buffer is full, it sends a message to sender side. Okay, sender, now please stop sending me the packets. I'm full. Okay, so by this using of buffer, the flow control is managed. Okay, so how transport layer manage flow control is by adding two buffers at sender side and at receiver side. What is a buffer? It is the set of memory locations that hold your packets. Okay, and whenever buffer is full, it inform your application layer or your senders. Okay, so this is how flow control is managed. Now let's see the second important control, that is error control. Now how error control is managed and what is the need to have error control. Okay, let's discuss it. Okay, so what is error control? If we want our transport layer to be reliable, right? Now how to achieve reliability in transport layer? So reliability can be achieved if we add error control mechanism, right? Reliability means it is reliable. It is, it should not have errors, right? So what is error control? What is the role of error control? What are the errors that can arise? First, you have to detect and discard the, duplicate packets. the duplicates packets which are sent by sender to receiver, right? Receiver receives two packets of same message, right? So they have to discard it. Then second, the sender should be known which packet it have to resend, right? If a packet is lost, which packet is lost, which packet is corrupted, right? Which packet arrived out of order. So all these things, it has to be known for all these errors, right? For all these errors, you need an error control mechanism, right? So how transport layer manages it? Now you can see here how you can avoid how the sender can know which packet I have to resend, which packet is lost, which packet is not received at the receiver end, which packet is duplicate, right? Which packet arrive out of order. So all these things are managed if you have a sequence number. Well, now what is a sequence number? Okay, so if sender sends like a packet to receiver, okay, if that packet is lost, okay, means the sender should be known which packet is had to resend, right? And receiver should be known okay, so this packet is duplicate and this packet arrived out of order. So how it can be done? If we number our packets, if the packets are numbered sequentially, right? How it can solve our problem? Let's think how it can solve our problem. If sender sends a packet 1 to receiver, okay, so receiver receives packet 1. Now again a sender sends packet 1. So receiver know, okay, now the packet number 1 is again sent to me. So it is a duplicate packet. I have to discard it, right? So first problem is solved. Now how sender know ki, okay, this packet I have to resend. If one packet is received, then it sends packet number 2, and packet number 2 is not received by the receiver. So it no, okay, one packet is received, now I have to send packet number 2 only, okay. And receiver no order also. If a gap come, like it receives one packet and third packet, and packet number 2 is not received by the receiver, so it know the gap, okay, so the gap here, I don't have received packet number 2, so it arrived out of order. Okay, so all problems can be solved if we add a sequence number. Now the application layer sends a message. So what transport layer does is transport layer add in header. It adds a header to it, right? So in header, it adds socket address and additional information. So additional information, it can add the sequence number also of the packet. Okay. Now the header should be in limit, right? You can't add now packet number 1, then 2, then 3, then infinity, right? You can't number packets like beyond a certain limit, right? You have to have a limit. So what limit you have? So if you have your header have m size of sequence number, then you can have the sequence number range from 0 to 2 power m minus 1. Okay, so let's suppose your m is 4. You have 4 numbers, 4 sequence numbers. Then 0 to 2 power m minus 1 is your range, means 0 to 15. Okay, like 0, 1, 2, then 15, then again 0, 1, 2, 3, and 15. Okay, so sequence number is modulo 2m. Okay, so how sequence number is range from modulo 2m. Okay, sequence number means it adds the number to packets. Okay, so that sender can know, okay, this packet is corrupt, this packet is lost, this packet I have to resend, or which packet is duplicate, which packet arrive out of order. So all these problems can be solved. Okay, the transport layer become reliable by adding sequence number. Then the second factor which can help transport to achieve error control is acknowledgement. Now, what is this acknowledgement? Okay, whenever sender sends a message, a packet to receiver, right? Transport layer sender sends that packet to receiver and to destination end, right? So now what happens? If receiver doesn't receive a packet, sender sends packet number 1 to receiver, and receiver then send packet number 2. Now if packet 2 is not received, is lost, then what happens? How sender know ki, okay, the receiver doesn't receive packet number 2, I have to resend it. How the sender know this thing? If the sender sends a packet 1 to receiver and receiver acknowledge it, okay, I have received packet number 1, then it send packet number 2. Then if receiver doesn't acknowledge, Then the sender come to know, okay, you have not acknowledged me, then that means you have not received packet number 2, so I have to resend it, right? So another thing is, for how much time the sender have to wait to receive an acknowledgement, right? So what happens whenever sender sends a packet to receiver, it starts a timer. Okay, and sender waits, timer goes on, and at a time, if a timer expires, timer stops. At that time, if the receiver doesn't acknowledge, so the sender can resend the packet. Okay, so acknowledgement means whenever receiver receives a packet, it sends an acknowledgement ki, okay, hi sender, I have received this packet, you don't have to resend it, now send me second packet. Okay, so this solves a problem of error control. So you need to have your transport layer reliable. Okay, so for that, what you can do, you can have sequence number, the packets that are numbered sequentially, and that is of modulo 2m. Then acknowledgement. Whenever receiver receives a packet, it sends an acknowledgement to the sender ki, okay, I have received this packet now. Okay, so this solves the problem of error control. Okay, so now let's see the third control, that is congestion. Okay, let's discuss the congestion control. Okay, so what is this congestion control now? What is congestion? Congestion means, in simple words, congestion means traffic jam. Okay, traffic jam. Okay, so traffic jam, not in road, traffic jam in network is called congestion. Means the congestion means load on the network. Means the rate at which a network can handle any packets is way higher than the rate it produces it. Sender sends so many packets to the network that network can't able to handle those packets. Okay, load on the network is increased. Okay, means traffic jam is increased on the network. So that is what congestion is. Means load on the network. Okay. So how we can avoid the congestion? We can avoid anything. Traffic jam can be avoided first if we prevent traffic jam. Traffic jam will not occur. Okay, and if traffic jam will occur, you have to cure it. So prevention and cure. So likewise, congestion can be prevented before it happens and after it happens. Okay, so it have two things: open loop congestion control and closed loop congestion control. Open loop and closed loop congestion control. Open loop is prevention. Okay, prevent congestion before it happens. Okay, you have to prevent congestion before it happens. Okay, its name is open loop because the information is not sent backwards. Acknowledgement information is of course sent, but not about congestion. If congestion is now increasing, now it is a verge to increase, the now congestion is increasing, right? So then it will not send information backwards from receiver into sender end. This information is not sent backward about the congestion. That's why it is not forming a loop. It is open loop. And in closed loop, it is cure. Now congestion happens. Now what to do? So what to do? The congestion control mechanism after congestion happens. Okay. So this is cure part. So it forms a loop. Why? Because information is sent backwards. If the congestion has occurred, so information is sent backwards. Okay, now you have to do something. Okay, congestion has already been occurred. Okay, so open loop has certain mechanisms. Retransmission policy. Right, retransmission policy means the packets, the sender send one packet to the receiver, right? It will not increase congestion, but when sender retransmit that packet only, then it will increase congestion, right? So there should be some mechanism which the sender should follow. Like sender can retransmit only that packet which is actually lost, which is actually corrupted, right? Then sender can have a timer at which time it should retransmit that message, which time it should retransmit which message, which packet, right? So it should have a retransmission policy. Okay, so that it can prevent our congestion to happen in future, right? Okay, it should be careful before only. Okay, then we have window policy. Window policy we will discuss in this later chapter only, when we discuss about transport layer protocols. There we will see two protocols: selective repeat and go back. There you will see that go back will it increase congestion to a very high extent, and selective repeat, it is advantage of using go back, means it avoids that disadvantage that go back have. Okay, so that window size of selective is way better than that of go back. Okay, that you will see in the later half of this chapter. Then next prevention method is return that acknowledgement policy. Right, acknowledgement policy. The receiver, if receiver acknowledge for each and every packet, then also it will increase congestion, right? So what receiver can do? Receiver can, receiver has a timer. Like within this time, I only acknowledge n packets, so that congestion will not increase in near future, right? If it acknowledge for each and every packet at one time only, then it increase congestion, right? So there should be acknowledgement policy, there should be retransmission policy, and window size should be, managed. Then closed loop. Closed loop, now congestion happens, what to do? So if congestion has happened, if traffic jam has happened, what can we do? We can cure the traffic jam. How? We can decrease the window size. Like the center window size is this much, means the center can take like 10 packets at a time. Now it increases congestion, right? So we have to reduce it to 5 packets or 4 packets or 7 packets, right? Now the window size is decreased. Now the center can only take 5 packets. So the congestion can start decreasing slowly, right? So this is the thing. And how window size is decreased, that we will see when we study about TCP protocol. Okay, so that we will see the policies and all. Okay, so what is congestion? Congestion means the traffic jam, the load on the network. Means sender sends so many packets to the network that network can't able to handle it. So it is congestion. So we can avoid congestion before and after. Prevention or cure. Open loop congestion control or closed loop congestion control. Okay, so that's we have discussed about all the 3 controls: flow control, error control, and congestion control of transport layer. Okay, so now in next video we will see about connection services and connection oriented services. Okay, so thank you.